Hello and welcome to this new video. Today I'm going to solve the case from the first battle of the Road to Las Vegas 2025, which is called We're Not in Kansas Anymore by Harry Gross. A very nice case, quite tough to be honest. This is also reflected in the scores of this first battle, but overall very nice. Supposed to be sort of a lambda breaker, and including a variety of topics that made it very difficult to go until the end in the 30 minutes. Having said that, let's go into the solve. The fun fact is that I already recorded a walkthrough for this, but found out that I had no audio, so I will need to record it again now. Let's start from the bonuses first. So first bonus asks how many yellow bricks have the digit 7 in their numbers, or maybe before it's better to show what you have as an input. So you have this sort of map in which you have single cells and numbers in each cells. Then you have this brick road, which is same thing but with merged cells. So you have those bricks of let's say 2 units horizontally and 1 unit vertically. Then you have this Wicked Witch Waterworks, which is a graph basically in which you need to consider a water source, potential connections going through the end. And then you have this Emerald City beautiful picture on which I already did some data prep and basically ran a macro to convert the colors into the hexadecimal codes because it took forever to run, so already did that. Okay, so bonus 1 asks how many yellow bricks have the digit 7 in their numbers. Use the yellow brick road. So what I'm gonna do, I think, is to turn this into a column like this and say minus minus if error find sorry, not is error find 7 here. So even if I have empty spaces, not gonna find any 7 in them, and I have the sum of 60, so that should be the answer for bonus 1, and that's it. Bonus 2 asks if Toto works straight down the Excel columns, what will be the maximum sum of the values of the bricks he works on? Use the map of yellow cell road. I think it's a quite straightforward one because you just need to sum like this. Okay, and the maximum is 3258. 3258. The incredible thing is that during the day I took the sum instead of the max, so I basically wasted 40 points here. Would have been top 5 score, also aligned with the seasonal goal I have, but no complaints. Bonus 3 asks you to consider this flying monkey named Lana spectating the battle on a tree, and the tree is located on the brick which has the highest total value of summing all adjacent bricks. What is the number of that brick? Use the yellow brick road, of course. Basically here the concept I use is that the number in each brick is contained in the leftmost cell of the group. If you want to move vertically, you cannot do that because you only can move diagonally. If you want to move diagonally, you can move a step 1 because you can see you move from a top left to another top left cell, also here, also going down right, etc. If you want to move horizontally, you will have to move by 2 because you will need to skip the empty piece of the group, and same thing to the left. So what I will do is first of all taking an A1, then I wanna use the arrows. Okay, and then as said, I would like to use a step of 2 horizontally and a step of 1 diagonally. So I will have something like this, and then I have a lambda to see what is the cell going in that direction. Of course, this is giving error because it goes outside the grid. And then I'm going to perform a very quick indirect to see what are the contents of those bricks. The request is located on the brick which has the highest total value of summing all addition bricks. Okay, so I'm gonna put an if error here. I'm gonna sum, and I'm gonna also return the content of the brick itself. Cool. Then I'm gonna see what's my range for the entire grid. Okay, I'm gonna filtering out the, let me delete this because I don't need it. And basically that's it, because I want to repeat for each cell, and then I'm interested in seeing the total, and I'm interested to see the brick. Gonna run the data table, cycling on A1. Okay, and I wanna find a maximum here, and I wanna X lookup this maximum value here, because I must sorry, here, returning here, because I must, which is the brick having the highest potential sum, and that's it. Then let me save this thing here. You are asked how many 3 brick horizontal triangles of yellow bricks that all touch each other add up to an even number. So A1, B1, B2, C2, C1, D1. So this, and so on. I'm gonna do this, I think, straight like this. So that's my first set of 3. Then I wanna see second set of 3. No, this is my second set. I don't need this. I don't need this. Okay, and then think I'm gonna need this. Then this. And that's it, I think. I don't need this. I don't need this. Seems like this is working nicely. Okay. And then I'm gonna copy like this. And this row, I don't need it. Okay. And then minus 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 is even. And I have 303 groups. which is the right answer. And last question asks, Dorothy wants to see how green is the Emerald City. What is the sum of the green elements in the RGB values of the Emerald City tab? For example, A1 is 109, which can be checked in the cell format menu. As said, already prepped this data in order to avoid waiting forever. On the internet, I eventually found that taking the number, dividing by 256, and then doing the mod 256 gives you the green component. The additional step you need is to round down, don't ask me why, to 0 decimal places. Will give you exactly the green component of the RGB and then you have 3084088 3084088, which is the right answer. Okay, going into the levels, you have for level 1 the same ask basically of bonus question 1, but for each column. So no, sorry, bonus question 2 probably was. You are asked to sum the contents of a given column. We already have the sum here in row 30, so what I can do is simply an indirect of maybe let's first of all rename this the shit. So this is the yellow cell road and this is the yellow brick road. So I wanna do an indirect of yellow cell road, this and 30, I think it was. Yes. And that's it. Level 2 asks you to find the distance between a given destination and A1. Plenty of way to do this. I have a lambda to calculate the distance between two cells without considering diagonal in this case, and then you need to have to add 1 because you are told that A1 already counts as one step. But the idea is to take the row distance, the column distance, and sum them in order to have the distance. Level 3, it's a little bit tricky, asks you to start from a cell, move to whichever remaining adjacent cells is the largest until the surrounding cells all have smaller values when compared to the cell in which you are in, and asks what is the sum of the path basically. I will leverage my solver worksheet for this. So example 3, you will start from J14. Again, I will leverage same idea I did here. So one formulas only. Okay. Cool. Then I wanna use my simple indirect yellow brick road. Sorry, yellow cell road, I think. Yellow cell road, yes. So in this case, no. I'm gonna use the full, or maybe diagonals are not allowed. Okay, so no diagonals. Okay, so the maximum is this. I'm gonna move current is the indirect of where I am. If this is greater than current, then 1 divided by 0. Next is x lookup of the maximum here, returning the set of options. Okay. And that's it. Need to lock this. Okay. Gonna say that if previous equals 0, then it's 0, otherwise the logic. Okay, and I wanna sum product those with the ones, and then I need to add also the first one only. Yes, and this checks out. Scale data table. Okay, we have an error on game 31. Yeah, of course, need to introduce an if error here. Otherwise, we're not gonna. Not sure the microphone is. Check. Okay. So okay. It's matching example. It's matching everything. Fine. Let me delete all this stuff. Okay, level 4 was where I overcomplicated my approach because I built the full algorithm without leveraging any particular smart step, managing that when I reached, for example, column X or W, I was going to add one row, move to, if it was W, it was Y, if it was X, it was I don't even remember, but you need to manage potential different starting cells according to which brick you are in, and same thing to the left. Crazy stuff. You're basically asked to figure out where you are after X steps and sum all the previous brick values. This is super simple if you stop for a second to think, because you could say that this is your sequence, and then you could reverse every second row horizontally, and that's it. And that's it, because this is level 3. Let's duplicate for level 4. I'm interested in doing a to call of that. And I also want to filter out the zeros. And I'm afraid you will just need to take to sum the take of, in this case it will be this. This is example 4. Yeah, look at it. Uh, don't even wanna know how long this took, because I think I spent potentially 15 minutes during the day. Come on. Level 5, I did very in a rush in the end, and was kind of proud of it because I think I had a very simple approach. Um, let me. I will not need the solver worksheet to do this, so I will probably do this here. Basically, you are asked, you wanna reach brick 96 starting from another given brick, and you wanna figure out how many steps you need to take. So what I did is, let's take the starting brick. I wanna find it. I will leverage a lambda I have into the lookup area because I wanna know the address of this. Same thing for brick 96. Okay. Then I want the coordinates of this, and I want the coordinates of this. So this is a row, column, row difference, column difference. Is the absolute value of one minus the other. Okay, I want to know the max and the min. So max of this and min of this. Why? Because I want to know the diagonal distance, which is always equal to the minimum, and I want to know the linear component, which is in this case the maximum minus the minimum. Cool. And the direction, and I want to say if column difference is greater than row difference, it will mean it will be columns, so vertically, otherwise rows, so horizontally. And I can compute the distance, and you can see that basically the distance is, looking at the example, if you move diagonally is one step always. If you move horizontally, you will need to basically consider this is a double step, and you cannot move vertically, or however, you can move vertically, of course, not just one step, otherwise it would be diagonal, but counts as a single step. So my distance will simply be the diagonal piece plus if this equals column, then I want to take the linear distance divided by 2, otherwise the linear distance like that. And I think we're good to go. So I think this is a very simple way to look at it. It works nicely. I don't know if I'm missing any edge case, but that's the way I did during the day. Level 6, I think it's quite simple, provided that you have the correct logic in place. So example 6. Example 6 asks you to start from a certain brick, and you want to check what is the smallest brick you can end on if you move 3 steps in any potential direction, or better, within 3 moves. So I will leverage the same structure I built here. So remove this ugly format. That's the list of cells I can potentially have to check. Okay. So yellow brick road. This. Didn't even need to copy this thing, but anyway. So. Okay. So the distance is like that. I'm going to say I want this. So column G. Because I want to compute the distance for every cell in the grid. Okay. Let me resize a bit. And then I want to see if and this is not this, otherwise it's the same one. And this is less than or equal 3, then it's 1, otherwise it's 0. Okay, and so I'm gonna filter those according to this, and I think I'm gonna do the minimum. Might be already good. And it is. Okay, very nice. Now, last but not least, we have this different beast here. Basically, the idea is that water starts flowing. Let me show it like this. Starts flowing from here. You have potential paths to follow. Each path has a capacity, so the capacity of the pipe. You have nodes, and a few of those nodes will be on for each given level. For example, in example, the green ones are the nodes which are on, and you can see that the only possible path to go from the source to the end is doing source 2, 5, 7, 10, end. And basically the amount of water that will reach the end is the minimum of the capacities of the on path, because of course if this is this has a capacity of 2, regardless of the other capacities which are higher, you will be constrained to flow 2 units of water per unit of time. So I think this is basic physics math. You don't need any critical knowledge of graph theory, even if that probably would help. I don't have it at this moment, so I will solve it raw without any specific algorithm. To be honest, I don't think this was doable in the 30 minutes allocation unless you leveraged at its best the preparation time, because what I'm gonna do now is to manually configure all the potential paths, which is a very time consuming task to do, but I don't see other options, so I will go into it with a bunch of options. I will go left to right in order to be structured. First path is water 1, 4, 6, 10, end. Okay, so it's the leftmost. 10 doesn't have other options, 6 doesn't have other option, 4 has other options, and in particular it has 2 options, so I will copy 1 and 4. The second option is 7, and now 7 has 3 options, so 10, 11, and 9, so I will need 3 times this, and I have again 10, 11, and 9. 10 goes to end, 11 goes to end, 9 goes to 12, and 10 goes to end. And I think one is gone because 4, yeah, that's one part. So let's move to 2. 2 can go into 4, 5, and 3. The good thing is that we already did 4, so I think I will do like this. Yes. Then I have another 2 which goes into 5, and 5 has the only option to go into 7, and 7 has 3 options, which are those ones. So we'll do like this. So 2, 5 has 3 options. Yes. And then you can have 2, 3, which can only go into 8, 9, 12, and then you have the direct, wow, it was spot on. And then you have the direct water 3, 8, 9, 12, and okay, that is cool. Okay, the other thing I will need is the connections between each nodes. So I will have the source, which is connected to 1, 2, and 3. Then I will have 1 which is only connected to 4. 2 is connected to 4, 5, and 3. 3 is only connected to 8. 4 is connected to 6 and 7. Yes. 5 is connected to 7. Yes. 6 is connected to 10. 7 is connected 3 times to 10, 11, and 9. 8 is connected to 9. 9 is connected to 12. 10 is connected to end. 11 and 12 all connected to end. And I want the capacity of those connections. So this has a value of 10, this is a value of 2, this is a value of 2. 1 into 4 is 8, 2 into 4 is 6, 2 into 5 is 6, 2 into 3 is 4. My eyes are crossing. 3 into 8 is 9, 4 into 6 is 10, 4 into 7 is 7, 5 into 7 is 6, 16 to 10 is 7, 7 to 10 is 10, 10, 1, 8 into 9 is 1, 9 into 12 is 2, 4, 5, and 9. Can you imagine the potential amount of mistakes here? And then I wanna text split my input over the rows, and I think that's it. So first of all, I want to find which of my paths is the eligible path. We are told that, thanks Harry, you can only have one path active at a time, so this probably simplifies things a bit. I want to check that. Let me add also this. I'm not sure. I'm gonna say if and if I do the countifs of this one into this, and for some of them I will need to have an additional step. Okay, and you can see No, and I'm interested in not considering the first and the last because W and D are never here. So I'm gonna drop the last and first. Bad choice. Okay, you can see this one as all ones. It is 2, 5, 7, 10 and, which is exactly the example, so good news for us. And I wanna say minus minus and of those. Okay, so this is my own path. So I wanna find my 1 over here, returning the potential paths. Okay, and I wanna filter any potential zeros, so filter x where x is not 0. Okay, okay. Now what I wanna see is whether any connection is active and is in path. So to be active, it means that both of the nodes should be, we'll need the start and the end. Both of the nodes should be in the active list. So this, or we'll leverage dynamic array, this equals this. Let's add something more. And or this equals this, one otherwise 0. Okay, so this does work for a longer sequence. And then I want to check same thing, but to see if this is in the path. Lock and lock. And so the combined of the two is the AND. So I'm gonna multiply the conditions. Okay, and I wanna take the minutes of those for the combined equal 1. Okay, this range is not dynamic, so I should be safe. Scale it a table and hopefully we have our answers, and yes. Okay, so again, a very nice case. So congrats to Harry in his new case for 2025. I liked it a lot. On bonus 5, I mixed feelings because I personally don't like those questions which require technical knowledge, so I was not aware at all of this trick to go from hexadecimal to RGB codes. But having said that, it's a bonus 5, so it's reasonable. So yeah, hope you enjoyed this video, found it clear enough. Let me know if you have any questions in the comment, and I will see you in the next one. Bye.